Hello and welcome to today's session. So, here we are looking at the application of sum and product of roots of a quadratic equation. So, in this video, we are told to find, we are going to see how we can find the value of k or the ranges of values of k in each case that has been given below. Okay, so the first case we have the roots of 3x squared minus 5x plus k is equal to 0. We are told that the first case is that they differ by 2. The second one, we are told the roots of 3x squared plus kx minus 1 minus x minus 2 is equal to 0 are equal and opposite. Then we are told where the roots are real and distinct, which it only has only root 3, and we are told has roots whose sum is equal to 6, and we are told has roots whose product is equal to 1 over 5, has real roots. So obviously you see that this is a combination of for real roots where you determine if the roots are real, if they are imaginary using the discriminant test. So now in this case, we are simply going to go direct to what we are supposed to find. So we're supposed to find the values of k. And in the first question, we are told these values of k, or uh, this equation has got uh, roots that differ by 2. Okay, so what does this mean? So now in this first question, we have 3x squared minus 5x plus k, and we are told this has roots that differ by 2. Okay, so meaning if you have alpha minus beta, their difference should be equal to 2. Okay, that is what you're supposed to have. And now you're using the what? You're using the identity test. We are going to use the identity for this, meaning you're going to square both sides. If you square both sides, you're going to have alpha minus beta squared, which will be equal to 2 squared, which will tend become 4. Now for alpha minus beta squared, this one here, you are going to use its identity. What is it? It is the same as alpha plus beta squared minus 4 alpha beta, which will be equal to what? Which will be equal to 4. So now in this case, since you already have the sum for this function that you're given here for this quadratic equation, so you're simply going to substitute where there is alpha plus beta, you're going to replace with the sum for this equation, which is 5 over 3. So 5 over 3 squared minus 4 alpha. So now here 4 alpha uh, beta. So now the product of this is the same as k divided by 3. In this case, you have got k over 3, which will be equal to what? Which will be equal to 4. Now here you are solving for the value of k. Okay, so you're going to have negative 4k over 3, which will be equal to this. It will be 25 over 9. When you take it on the other side, you're going to subtract from 4, and you're simply going to end up with 11 over 9. Now you want to find the value of k here. So meaning you are going to divide both sides by negative 4 over 3 and negative 4 over 3. And in turn, you are going to end up with negative 11 over 12, which is the value of k in that case. So now, if you want to see this clearly, there is an alternative again. If you want, you can use another method. Which method is that? Which is this method here. You are saying, let the two real roots be alpha and alpha plus 2 because they differ by 2. Now, when you get the sum of these two roots, you're going to have alpha plus 2. So, which we are going to equate it with the sum of the original equation, okay, which is 5 over 3. So now in this case, your idea is you want to find the value of alpha, okay. So you're going to have alpha plus alpha, you're going to have 2 alpha plus 2, which will be equal to 5 over 3. In this case, you are solving for the value of what? For the value of alpha here. So now after solving for the value of alpha, this you're going to have 2 alpha, which will be equal to this 2. When it goes this side becomes positive. So you're going to have 5 over 3 minus 2. Whatever value that you're going to find, you're dividing that by 2 alpha. So meaning the value of alpha will be equal to 1 over 6. That is what you're going to find. Now, since we found the value of alpha, we want to find the product. So meaning alpha times alpha plus 2 is equal to the product of the original function, because we are interested in finding the value of k, which will be k over 3. Okay, so now here finding the value of k, when you simplify, you want to find the value of k. That is what you want to find. So now if you want to find the value of k, you're simply going to substitute with alpha, because you have been given what alpha is, and alpha we found that it was negative 1 over 6. So if you factor out everything here, you're going to have negative 11 over 12. Same with this one, we are told the roots are equal but opposite. Okay, meaning one is positive and the other one is negative. When you take the sum of, for example, we are saying we have got alpha and negative alpha. When you add these two, they are going to give us what? They are going to give us 0. And what is the product of this? I mean, what is the sum of this? It is negative k minus 1, okay, over divided by 3, which is this one here. And this, because the sum for those two roots is equal to 0, you're going to equate to 0. Then you solve for k. K here is simply equal to what? Will be equal to 1, because here you're going to cross multiply 3 times 0 to be 0. So you're going to have negative k minus 1, which will be equal to what? 0. Then when you simplify this is negative k plus 1. When 1 goes the other side, you're dividing by a negative. You're simply going to find the value of k, which is simply equal to what? Which is equal to 1. That is what you're supposed to do. So now we move to the third question. Okay, the third question is saying, here we are simply using the determinant test, because what is it saying? It's saying the roots which are what? Are real. And in this case, when the roots are real, okay, meaning the discriminant is what? The discriminant is greater than 0. Okay, that is when you're going to have two distinct real roots. So now in this case, it's the same understanding, because we want to find the value of k. That is what you're interested in finding. So now you identify your B, you identify your C, and you identify your A. Then from there, you're going to use the discriminant test, which is given, the discriminant which is given by b squared minus 4ac, and in this case, it should be greater than 0. Then you simply substitute all these values in that equation. Then from there, you're going to end up with a quadratic equation that looks like this. When you simplify this, you're going to find that the only critical value that you're going to have 2. Now you're going to do a table test. You're going to test, you want to know which region satisfies the quadratic equation that you've been given. Where is it positive? Okay. So now in this case, we are seeing that even if you have to pick a number, any point from the left of negative 2, when you substitute it in there, it will be positive. If you get 0 there, you replace there, you're going to get a positive value. This side, if you get a positive number to the right side of 2, it's still going to give you positive, meaning everywhere this uh, situation, the value of x is satisfied using the condition that you've been given. Okay, that is what you have for that particular question. Okay, so you can still go on and on. Here in the third question, we are told it only has root 3, meaning the only root which is there, it is what? 3. So you simply get your 3 here. You're going to get your 3 and substitute it in the equation. Then you're going to find the value of what? The value of k. You are done. There is nothing like, why is the question too simple? No, that is what the understanding, and that is how you're supposed to solve it. Now for this one, you're told 3x squared plus kx minus 2 has the roots whose sum is what? Whose sum is 6. Meaning when you add those two roots, the sum is 6. So now you want to find the value of k. So from here, identify what is the sum of k. The sum of roots is given by negative b over a. In this case, we are going to have negative what? Negative k divided by what? Divided by 3. And that you're going to equate it to what? To the sum of what you've been told in that case, which is 6. So from there, solving for k, and k is simply equal to what? Negative 18. That is what you're going to find. Okay, that is the situation, and that is what you're going to find. In this case, you're told it has roots whose product is what? 1 over 5. In this case, find alpha times beta, it's the same as 1 over 5. Then now you want to find the value of k. What is the product of roots? It is c over a. In this case, you have got k over 5. So that k over 5, you're going to equate it to what? To what you've been given that condition, which is 1 over 5 for the product of those roots. Then you solve for the value of k in that case. Okay, you're going to solve for the value of k. You still do the same for all these. It's the same understanding for these specific questions. So the understanding, this is where you apply what you've learned about the product and sum of roots, the identities for that, including what you know about the discriminant when you're testing which solution is giving you real roots, and what condition allows you to find complex roots, and what conditions allows you to find what? One root, okay, or two equal roots in that case. That is what you're going to have. So that is the understanding. So you're simply applying the principles that you've learned in this situation now. Thank you for watching this video, and I hope it was educative and enlightening on how you're going to solve such kind of questions. If you have any questions, please kindly drop them in the chat box. Thank you for watching. Please share and subscribe.